Today's video is over simplifying radical expressions. Before we begin, we have a couple properties of radicals to cover. Multiplication property of radicals. This states that if you have the nth root of a times the nth root of b, the roots are the same, then you can combine them and make them 1. Or, opposite of this, if you have two factors under a radical, then you can split them up so that you can simplify or evaluate the ones that can evaluate. We also have the division of that. So if you have two radicals with the same index, which the index is this number here, you can combine them in one square root or nth root, and same goes as the other way. If you have a fraction under the nth root, you can split the numerator and denominator up into each of the nth roots to simplify further. So when we simplify radical expressions, they are simplified when 1, there are no fractions, or negative exponents. 2, no radicals appear in the denominator. And 3, no more numbers can break out of jail, which we will see here in a little bit, or there are no more perfect numbers, meaning you cannot simplify it further. So there are two methods that we will cover, which the second method is my favorite. So the first method is breaking up the radical, or in this case factoring the radicals, such that there are perfect numbers. So when you factor the number, or you break up the radical so that you have perfect numbers under the radical to simplify, and then the rest of it is just simplified, already simplified, like square root 3 cannot be simplified any further. Or my favorite is we break numbers up, or factor the numbers into prime factors and break numbers out of jail. I'll show you both methods with the first one, and then continue on with the breaking out of jail method. So for instance, we have square root of 12. The first method involves knowing your perfect numbers and what perfect number can go into 12. Well, we can break up 12 into square root of 4 and square root of 3. Well, square root of 4 is 2, and square root of 3 is just square root of 3. And we're simplified. Now, simple numbers like 12 are easy to think of, but when we get into the larger numbers, they're a little harder to think about. The other method, break out of jail, is you would have to factor these numbers into prime factors. The index here is a 2. Square root would mean 2, so it takes 2 to break 1 out of jail. So we have one pair of 2's and then a 3 remaining. So the rule is, since we have a square root, it takes 2 to break 1 out of jail. So since we have one group of 2, one breaks free, the other, you can use your imagination. And then this 3 has no partner, so he stays in jail. Let's work 300. 300 is a little easier as well, because we can break it up into square root of 100 and square root 3. Square root of 100 is 10, and square root of 3 is just 3. But if you're not familiar with the perfect squares, especially with numbers that you really have to think about, you can factor 300 into prime factors. Now the 6 and the 30 and the 100 we don't need because they have been factored. We have a pair of 2's and a pair of 5's. So a 2 and a 5 will break out of jail. And then the 3 is all alone, so we keep the 3 in jail. 2 times 5 is 10. Radical 3. Now the rule here is, if you have outside numbers, you can multiply them. If you have a few inside numbers, you can multiply them, but you cannot take outside numbers times inside numbers. We cannot combine them in that fashion. If we have cubed root of 72, this time we have cube root, so it will we will need 3 numbers to break out of jail. So a group of 3 numbers will break one loose. Let's see, that will be 9 and 8. 8 is 2 times 2 times 2, and 9 is 3 times 3. Or you could have broken 8 up into 4 and 2, and then the 4 would break up into 2 and 2. So it takes 3 to break 1 out of jail. So we have 3 2's, so one of the 2's come out. And then we have 2 3's here, but we actually need 3 numbers, not 2. So these guys can't break out. So 3 times 3 is 9. Do not forget your index. So we have 2 cubed root. I'll rewrite it. 2 cubed root 9. Now we can also involve variables. So the square root of 24x to the 5th. Now remember, it takes 2 to break 1 out of jail on this one because we're in terms of square root. So we will break these numbers up. And as you go along, you will probably know, oh, 6, I don't need, or 6 is probably, no, cut that. For instance, I have 2 and 2 here, and then I know 6 is 3 and 2, so I did not necessarily have to break 6 up, but just to be on the safe side, factor everything until it's prime factors. There's a group of 2's, so a 2 comes out, and then the 3 and 2 stay in, which brings us back to 6. Now our numbers here, remember it takes 2 to break 1 out of jail. So for instance, we have 5 x's. We take 2 at a time. So we have 2 groups of x's, so that'd be x squared, and then we have an x remaining. Now with the square root, if you have an odd number, you will always have a remainder of 1. Another way to look at this is you take your exponent and divide it by 2. 5 divided by 2 is 2, so we get 2 whole numbers. And then we'll have 1 remaining. 2 times 2 is 4. 5 minus 4 is 1. Or if you need to, write it all out. Okay, so 72, or cubed root 72, a to the third, b to the sixth, c to the seventh. So first, well, let's work our number. So 72 is 6 and 9, no, 8 and 9, excuse me, I'm sorry, 8 and 9, and then 8 is 2, 2 and 2, and 9 is 3 and 3, which we broke it up here, since it takes 3 to break 1 out of jail. So we have a pair, or triple of 2s. So we have one group of 2, and then our 3 stay in, so we will have a cube root of 9. And then with our variables, well, we have 3 a's, which that would give us one group. So 3 divided by 3 is 1. B to the 6, 6 divided by 3 is 2. Or we have 2 groups of 3. And then c to the 7th, we'll have 2 groups of 3, so c to the 2nd, and then we'll have 1 remaining. So this will be 2ab squared c squared square root 9c. So 7 divided by 3, 3 can go into 7 2 times, so 3 times 2 is 6, so we'll have 1 remaining. Or we'll have 2 groups of c's and then 1 remaining if you need to write it out. So with the cubed root, you will have either 1 remainder or 2 remainders. With square root, you'll only have 1 remainder if needed. And then with 4th root, 5th root, 6th root, just take your root, subtract 1, and then it will be one of those numbers. So for instance, cubed root of 4, subtract 1, that will be 3, so you'll have either 3, 2, or a 1 remainder. So 28, x to the third, y to the third. You may pause the video here to work on this. The answer will be, if you break up 28, you have a group of 2, and then you'll have a 7 remaining, and then we have x to the third, y to the third, so that means we have 3 x's, we have a group of x's, and 1 stays. Or 3 divided by 2 is 1, which stays outside, and then we'll have 1 remaining. Square root a to the 5th, b to the 7th. If you'd like to pause the video and work on it by yourself, do so. The answer, 5 divided by 2, we get 2 whole numbers, and then we have 1 left over, or a remainder of 1. With 7 divided by 2 is 3. We can get 3 wholes out of 7, and then let's see, 7 divided by 2 is 3, and then we'll have 1 remaining. Cubed root 200, x to the 8th, y to the 12th. You may pause the video to work on this one. The answer, we'll have 20 times 10, 4 and 5, 5 and 2, 2 and 2. Okay, and then it takes, we have 3, so 3 takes 3 to break 1 out of jail. So we have a 2 broken out, and then we have a pair of 5s, but they can't break out, so 5 times 5 is 25. They're still in jail, so it's like saying square root of 5 times square root of 5. Then we have x to the 8th. 8 divided by 3, well, 3 can go into 8 twice. 3 times 2 is 6, so that means we'll have a remainder of 2. And then y to the 12th, cubed root of y to the 12th, 12 divided by 3 is 4 with 0 remainders. So we will not have any y's under the square root, or cubed root at this point. And please do not forget your index. I do that multiple times and catch myself. This will conclude this video.